on camera. We are live. All right, so we are going to do 3.4 today, which is real zeros of a polynomial function. Okay. All right, so we're going to talk about, remember yesterday I said those theorems weren't all that helpful. Today is going to be really helpful. We're going to talk about the rational zeros theorem. THM for theorem, okay? So if the polynomial p of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus, and then I can have as many terms as I need in here, plus a sub 1x plus a sub 0. Okay, so we've got a polynomial function that is of that form, and it has integer coefficients where a sub n does not equal 0 and a sub 0 does not equal 0, then rational 0 of P is of the form P divided by Q, where P, or this way, P is a factor of a sub 0 and Q is a factor of a sub n. Okay? So this is going to be a very important theorem, and we'll tell you what that means. Okay? So the easiest thing to remember is the most important numbers in this case are the coefficient of the leading degree and this one, at least the constant term. Okay? So let me do an example here. And let's say that I've got some function p of x equals x cubed minus 3x plus 2. And I tell you I want you to factor that. Okay? Now, you probably don't really have any good techniques. And so we're going to come up with some techniques. Now basically what this says here is I need to find my p's and my q's. Okay? P's are all the factors of my constant term. So Daniel, what are all the possible factors of 2?
These are the what?
All the factors of the number 2.
Okay, the factors are 2.
Yeah, 1 and 2. And they could be positive or negative, right? Okay. What are the factors of that term right there? Let's stay with Daniel since that was such an easy question.
1.
1. Plus or minus 1. Okay. So Nathan Allred, let me ask you a question here. How many possible zeros are there for this problem here? 3. How did you come up with 3?
Wild guess.
Wild guess?
Yes.
Oh, well, actually the right answer. You're a good guesser. Why do you think it's 3s?
The x is cubed.
X is cubed, that's exactly right. You've got a degree 3, so you're going to have at most 3. You could have fewer than that, but at most you could have 3 zeros, right? So at most 3. Okay? All right. And in fact, you will have 3, some of them, in fact, later on, I didn't tell my other classes, later on we'll find the imaginary ones. But for today, we're going to just stick with the real ones. Okay? So now we've got really, so the idea with the rational zeros theorem is basically I'm going to take every possible combination of p divided by q. So all of the possible combinations are going to be plus or minus 1 divided by plus or minus 1, and plus or minus 2 divided by plus or minus 1. Okay? So actually, in this case, I've got 4 possibilities. I know I'm going to have at most 3, so at least one of these is not going to work. Okay? Does that make sense? Okay? So we're just going to guess. And Hallie, if you were going to guess, which one would you want to try first?
If I'm guessing what I want to divide by, like either 1 divided by 1 or 1.
Yeah, let's go with positive 1. Okay? And so let's do some synthetic division here. What are my coefficients?
1, -3,
Oh,
0, 0. Oh,
you promised. 1, 0,
-3.
-3, and 2, right? Don't forget the 0, okay? Y'all promised me you weren't going to forget that, okay? All right, so Hallie, let's finish this off with synthetic division. We're going to get 1
times 1 is 1.
1,
Plus 0 is 1.
1,
Times 1 is 1.
1,
-3 plus 1 is -2.
-2,
Times 1 is -2.
-2,
0.
and we got lucky. We got a 0 there, right? Okay, so 1 is a 0. How would I write that as a factor? Right, this is a factor.
X minus 1.
X minus 1. And then this is the rest. What does this represent?
X squared
X squared
plus X
plus X
next.
minus 2. Can we factor this?
Yes, -1 and 1.
Okay. Factors of X squared are
X,
X and X. Factors of 2,
1
1 and 2,
One.
right? And I'm just going to bring this down, X minus 1. Okay, now I'm just going to get my signs right. I did a positive 1 here, so this becomes a negative and a positive, right?
Yeah.
So positive 2 minus 1 is 1, and negative times positive is a negative, okay? So I have zeros at where?
1,
1 with a multiplicity of,
1,
nope,
2,
2, because that's the same thing twice, right? And I've got -2 with a multiplicity of
1.
1. Now, I didn't ask you this, but we could graph this really easily. The power function would be
Y equals
x cubed. I've got a 0 at 1, and I've got a 0 at -2. My power function is going to start low. We're going to come up here to -2, and we're going to cross it. And we're going to go to 1, and we're going to bounce. Boom. Okay, so we got pretty lucky there. She guessed the 1. Now, by the way, so the positive 1 was actually used twice. Okay? So that was nice and lucky in that we guessed right on the first try, and then we could factor it. But essentially, that's what this entire section is going to be about. Okay? So, now I will tell you also this. I'm going to give you some questions, and it will say just list all of the possible zeros. And so we're going to give every possible combination of this fraction here. Okay? Now, would you like to not have to guess? Okay? So one of the ways we can decide on, oh, you didn't tell me that was off screen, but one of the ways that we can narrow down our choices, this isn't perfect, but we can narrow them down, is to use what's called Descartes' rule of signs. Okay, now by the way, this graph here, where we're plotting points, do you know what that's actually called? It's called the Cartesian coordinate system. And the reason why it's called the Cartesian coordinate system was because it was created, it was created by Descartes, and we just chopped off the DES, okay? He's the guy who came up with this. And so that's why we call it the Cartesian coordinate system. So this guy was really smart, okay? Now, so essentially what we're going to do is we're going to keep doing this, list all your possibilities. That could be a nice, good test question. Maybe I'll give you something like x to the 7th. And then I would say list out all the possible zeros, okay? And maybe we'll make it a little more complicated than that. So that would be kind of fun. But the idea here is, we know, I'll leave this back at 3 the way it was, okay? We know we're going to have at most 3, but it would be nice to narrow them down, okay? And so the idea here is, with rule number 1, Descartes' rule of signs, we're going to let P be a polynomial with real coefficients. Okay? And so rule number 1 says the number of positive zeros of P of x is equal to the number of variations in sign in P of x, or is less than by an even whole number. Okay? So let's look at how Descartes' rule of signs would have applied to our last problem that we just did. Okay? Let me turn up the light. I think it's a little easier to see for the people who are watching this at home. Okay? So as we look at our original function here, notice this is a positive x, right? Okay, positive x cubed. So if I go from positive to a negative, that's one change in sign. And if I go from a negative back to a positive, that's another change in sign. Okay, so I've got 2 changes in sign. Okay, now remember, my most I'm going to have is 3 zeros. Okay, so what Descartes' rule of signs says is, okay, so I've got 2 changes in sign here, so I'm going to have 2 or 0 positive zeros. Okay, so you're always going to decrease by an even number. So if this was, let's say this was x to the 7th per minute. Okay, only had 2 changes in sign. Okay, so I'm still going to have at most 2 or 0 positives. Okay, so the idea here is, let's say I'm going along here, pretend this is x to the 7th. I found positive 1 worked, and I found positive 1 worked again. Okay, when I'm going through this list, which is probably going to be a lot longer than this, I don't need to try any more positives. They're all going to be negatives from here on, right? Okay, so that's what Descartes' rule of signs would say. Okay, does that make sense? Okay, so let's go with rule number 2. Okay, now we need to figure out how many negative zeros we would have. So rule number 2 says the number of negative real zeros of p of x is equal to the number of changes in sign in p of minus x, or is less than by an even whole number. Okay? So essentially what that means, I'm going to leave this x to the 7th here for just a moment, okay? So with an x to the 7th here, how many possible zeros am I going to have? Should we go back to Nathan?
Oh, 7.
We're going to have 7, okay? So according to the Descartes rule of signs, I've got 2 changes in sign, so I'm going to have 2 or 0 positive zeros, okay? Now, let's figure out the number of negative zeros. By deduction, we could have, if I've got 2 positives, how many negatives am I going to have at most? Thought that was an easy question. I'm going to have what?
2 or 0.
No, because I'm going to have 7 roots here, right? So if I've got 2 positives, how many negatives am I going to have? I'm going to have 5, right? So that's one way to think about this without going through this. But let's go through this again, okay? According to this, now I need to find p of minus x. P of minus x would be negative x to the 7th plus, no, sorry, that's a minus, minus 3 times negative x plus 2. Okay? So according to Descartes' rule of signs here, if I simplify this, this becomes what, Michael?
Negative x to the 7th
Negative x to the 7th
plus 3x
plus 3x
plus 2.
plus 2. Okay? So as I look at my change of signs in this case, I'm going to have, I've got 1 change of sign, right? Is there a change of sign again? No. Okay? So this is kind of nice because what this says is I'm going to have 1 or 0 negative zeros. I'm talking about real zeros. Okay? So if this is really my problem, x to the 7th, I'm going to have at most 2 positives and at most 1 negative. What does that mean about all my other roots? All of my other zeros? They're probably going to be imaginary. Okay? So once I've found at most 3 of these, I'm not going to keep looking because they're going to be imaginary. Or if I keep looking, just know that they're imaginary. Okay? So there's no reason to find all 7 in this case. Does that make sense? Okay? So that will help you narrow this down. Don't keep trying. Okay? So let's do another example here. I'm going to switch over here to Descartes' rule of signs. Okay, so use Descartes' rule of signs to determine the possible number of positive and negative zeros. P of x equals 3x to the 6th plus 4x to the 5th plus 3x cubed minus x minus 3. Okay? So, Javier, it must be your turn. How many, in fact, we'll do a couple things here. First of all, let's figure out our positive zeros. Question, John? No, you want to help them out? Oh, I'm going to have Javier do this. So we need to count our changes in sign, right? Okay, so that's a positive 3. Is that a change in sign? No. Is that a change in sign?
No.
Is that a change in sign?
Yeah.
So I've got 1. Is that a change in sign?
No.
So what's the most number of positive zeros I'm going to have?
1.
1 or
0.
0. Okay? Now let's go with the negative zeros. According to Descartes' rule of signs, what do I have to do now?
P of negative x.
I need to find P of negative x. So what is P of negative x?
3 negative x.
3 times negative x to the
6
6 plus 4 times
negative x to the 5th.
negative x to the 5th plus 3 times
Negative x to the 3rd.
negative x to the 3rd plus or minus
Negative x.
negative x minus 3, right? Okay, let's simplify. So this becomes negative to the 6th power is
Positive.
positive. So this is 3x to the 6th. Negative to the 5th power,
Negative.
negative times 4.
Negative 4.
Negative 4x to the 5th. Negative to the 3rd power,
Negative.
negative times 3.
Negative 3.
Negative 3x to the 3rd. Negative times negative,
Positive x.
positive x, and
Minus 3.
minus 3. Okay, so now we need to start counting our changes in sign. Do I have a change in sign?
Yeah.
Yes, so that's 1. Still 1,
2.
2,
3.
3. Okay, so the possible number of negative zeros are
3 or 1.
3 or 1 or 0. Okay, now how many possible zeros am I going to have?
6.
6. Okay, all, at most, only 4 of them are going to be real. Okay, 2 of them are going to be imaginary. And we will find those imaginaries, but we're not going to worry about that in section 3.4. Yes?
The 3x to the 6th is 3 times negative x. Wouldn't it be negative 3x to the 6th?
No, because your order of operations, you do this first.
Sure.
Negative to the 6th makes it positive.
All right.
Okay?
Yeah.
Good question. Now, let's figure out our P's and our Q's. Okay? If we're going to do this, we're probably going to run out of time here, but what would be all of my P's, Laura? P's are factor of which terms? The last term. What are your factors of 3? Okay, so plus or minus 1, plus or minus 3, right? What are your Q's? The first one. Okay, so what are my factors of 3? Plus or minus 1, plus or minus 3. Now I need to find all the possible combinations. Okay, so 1 divided by 1 is, so I've got plus or minus 1. 3 divided by 1 is 3. 1 divided by 1 again, still 1, so I don't need to rewrite that one. 1 divided by 3, plus or minus 3, okay? So I have 6 choices, but at most, only 4 of these are going to work.
Wait, so 1 divided by 3?
I think you meant 1/3. not
1/3.
1/3. I said it and I didn't write it, did I? Okay? Hopefully the pen can stand with my mouth. Okay? All right. So yeah, so these are going to be my 6 choices, right? Essentially, because I've got plus and minus. Okay? if we were gonna do this, what would we do? I don't think it actually asks you to solve this, but heck, let's try it, see what happens.
Guess a -1.
You wanna guess a -1, because you think there's probably more chances for a negative, right? Okay, let's go with -1. We're gonna go as far as we can in the time we have left and just keep going, and then we'll call it a day. Now, before we do, because I know, well, maybe we'll stop, because we're out of time. So here's what I'm gonna say. We have some other rules to help us narrow this down. I'm gonna stop here on Descartes' rule of sign, so we're not done with 3.4. But as far as the quiz, let's say the first page there on page 319, so up through problem 19, that'll be your quiz for tomorrow, is up through 19. And then we'll finish this section tomorrow. Sound good?
So questions 1 through 19.
Well, it's
Well,
not all of
1%
them,
in
but
there.
yeah, whatever I got up to. Okay? See y'all tomorrow.